Hello, my name is Daphne Chen, and today I will be going over question 20 of the 2021 Fall AMC 10A. So the question says that how many ordered pairs of positive integers b, c exist where both x squared plus bx plus c is equal to 0 and x squared plus cx plus b is equal to 0 do not have distinct real solutions? And the answer choices are 4, 6, 8, 10, and 12. So before we move on to how to solve this problem, we have to learn some important information points. For this question, it is the discriminant of the quadratic equation. So it is usually represented with the Greek letter delta. And in the quadratic equation, ax squared plus bx plus c is equal to 0. It is b squared minus 4ac. So for this discriminant, there are three cases. When the discriminant is greater than 0, which means there are two real solutions. When it is equal to 0, which means there is one real solution. And when it is less than 0, so there are no real solutions. And so in this case, the solution is like the x-intercept for this graph. So y is equal to 0. So the first case is when there are two real solutions. As you can see, there are 2 points in which this parabola intersects with the x-axis. And the equation of this parabola is x squared minus 4x plus 2 is equal to 0. And we can plug it into the formula b squared minus 4ac, and we can see it's negative 4 squared minus 4 times 1 times 2, which is 16 minus 8, which is equal to 8. And 8 is greater than 0, so two real solutions exist. The second case is when there is one real solution. As you can see, there's one point in which this parabola intersects with the x-axis. And the equation of this parabola is 3x squared minus 6x plus 3. And we can plug it into the formula. So negative 6 squared minus 4 times 3 times 3 is equal to 36 minus 36, which is equal to 0. And 0 is equal to 0, so that means there's one real solution. The third case is when there is no real solutions. So as you can see, this is the x-axis, and this parabola does not intersect with it at all. So the equation of this parabola is 2x squared minus 6x plus 5 is equal to 0. And if you put it into the formula, then negative 6 squared minus 4 times 2 times 5 is equal to 36 minus 40, which is negative 4. And negative 4 is less than 0, so no real solutions exist. So now we can move on to this question 20 and how to solve it. So first note that in this question it says distinct real solutions. And so this has an S, so there are two solutions. It does not have two solutions, so it has either 0 or 1 solution. So for the quadratic equation x squared plus bx plus c is equal to 0, the discriminant is that b squared minus 4x is less than or equal to 0. So b squared is less than 4c. And then we have the equation x squared plus cx plus b is equal to 0. So c squared minus 4b is less than or equal to 0. So c squared is less than or equal to 4b. And we want this 4c to somehow be related to the c squared. So we want the c term to become a c squared term, but we don't want a c term on the left side of this inequality. So what we do is we square it to get b to the 4th is less than or equal to 16c squared. And then if we want the c squared to also match up with 16c squared, we multiply this inequality by 16 to get 16c squared is less than or equal to 64b. So we can connect these two inequalities together to get b to the fourth is less than or equal to 16c squared, which is less than or equal to 64b. And now we can go on to the next part of solving this problem, which is casework. So when b is equal to 1, 1 is less than or equal to 16c squared, which is less than or equal to 64. So c can be either 1 or 2 to satisfy these requirements. So the ordered pairs are 1, 1 and 1, 2. And when b is equal to 2, well, 16 is less than or equal to 16c squared, which is less than or equal to 128. So c can be either 1 or 2, which means that the ordered pairs are either 2, 1 or 2, 2. And then when c is equal to 3, 81 is less than or equal to 16c squared, which is less than or equal to 192. So c is equal to 3 to satisfy this. And then when b is equal to 4, 256 is less than or equal to 16c squared, which is less than or equal to 256. So the ordered pair is 4, 4. And you can see if b is equal to 5, this number on the left will be greater than this number on the right, which would mean that there are no solutions. So now we have to figure out how many pairs there are, and we can just count them. 1, 2, 3, 4, 5, 6. So there are 6 pairs, so the correct answer is B, which is 6. And then now we can see quadratic equations, the real-world applications for them. So there are actually a lot of real-world applications for quadratic equations. So for example, if you throw a ball into the air, you can use a parabola to graph the relationship between the height of the ball from the ground and the time elapsed. Or we can see if we have an object we are selling, then we can use it to see, like, if the price increases, then maybe the amount of the object sold decreases. And we can find out, using this parabola, how to maximize our profits. Or we can have an object and we know the perimeter of it, and then we can see how to maximize the area using a parabola. And there are also many other examples. These are only some of them. But as you can see, quadratic equations, they're really useful in the real world. They're also a lot of fun to work with. And thank you everyone for listening, and see you next time.